Thanks, Michael. So as you may be able to tell from the slide here, I've dropped the with LabVIEW part because when I started doing the demonstrations, it was lacking on the LabVIEW front. So apologies for that, but we will look at some of the LabVIEW interactions with TestStand. So some of the custom UI side of things and what to put into a LabVIEW VI so that TestStand can communicate to it. But we'll mainly look at standardizing your testing processes by modifying the process model. So first off, I want to start with a giant's a female, and some of you may know Hannah Wade. She works for National Instruments, and she's now the Director of Global Sales Operations for NI. But when I knew her from NI UK, well, actually, prior to my joining NI UK, met Hannah at Loughborough University, or as Australians like to call it, Luga Baruga University, where she actually first taught me to use LabVIEW. So it was very first touch point during my undergrad degree in systems engineering, and Hannah and Bijal Tucker both came along and taught us some courses. It got us up and going with some systems integration, where we had a competition run. So everyone was split into groups of about 5 odd students. We were given a chassis which we had to solder and assemble, which is basically just a bunch of LEDs and a fan, and then interface that through a USB to the computer, use LabVIEW to control that car chassis, in inverted commas, and make a LabVIEW UI to drive around or do something autonomous. And there was a competition, and touching on what Eli was talking about earlier, I wanted to highlight the academic influence that Hannah had on me, and by having this little anecdote, 'cause our team actually won the first prize, and each of us got £100 reward. It's about 200 Aussie dollars, which is pretty good for a student. And with that small recruitment fee, I was hooked on LabVIEW for the next 13 years, and it's really set me up for my career and now working for software. So yeah, thanks, Hannah, for setting me up on a hopefully lifelong career path. Hopefully she doesn't mind it. I didn't ask. So I'll go through a brief introduction of who I am, what a process model is in TestStand, and why we might want to modify it and why we might not want to modify it. Some of the execution entry points, callbacks, configuration entry points, which are all components of a process model. And we'll go into some demos of how to modify those and how we've modified them for some of our customers at software. And I'll touch briefly on UI interactions if I've got time at the end, and maybe show you a little demo on that front before we close for questions. So I'm not going to go into model plugins, and I'll sort of explain why as we go through. But I'm also not going to touch on the parallel and batch models that ship with TestStand, but you can take the information I'm talking about here and apply it to the batch and parallel processing as well. You've just got to think more in a parallel stream, and I didn't want to have to do that for this presentation. So yeah, come talk to me afterwards if you want to talk parallel and batch. So who am I? I'm Pete Woodward. I'm Senior Systems Integrator for Software Systems. I also lead the test and automation team, which operate in Sydney, Adelaide, Melbourne, and myself down in Tasmania and Hobart. I've been using LabVIEW since Hannah first taught me back in 2012, and been with software for the last 7 years, where I've been using LabVIEW, TestStand, and VeriStand. Certified LabVIEW architect, TestStand developer, professional instructor, all of those C's. And prior to that, I worked at National Instruments in the UK, where I was an inside sales engineer and the standard applications engineer, going through the engineering leadership program, where I spent about 3 years in the UK office before coming off to Australia. And during that time, I taught numerous courses, around 30 odd, both TestStand and LabVIEW in various countries all over Europe, wherever NI wanted to send me. So that's pretty good. And TestStand wise, who has actually seen and used TestStand before? Quick show of hands. Okay, that's 50% of the room, which is much more than I thought, so maybe I need to make it much more technical than I was anticipating. How many people use it regularly still? Okay. Less. So, okay, we'll keep it at a sort of beginner level, and you can tell me if you want more detail in the question section. But the NI blurb is basically TestStand is an off-the-shelf test management software for validation and production test that eliminates the need for time-intensive in-house sequencer development and maintenance. However, As Eli sort of mentioned in his presentation, sometimes you want to customize those processes, make it adapting to your business needs, and that's where you might want to adapt the process model, potentially. So what is the process model? So if I can mouse over. So process model lives in the framework of TestStand. It sits just above the TestStand engine that's running in the background. TestStand engine basically handles all of the functions inside of TestStand, and every time you call a step, there's certain features that happen running in the engine. The framework sits on top of that and adds a layer of customization. There's 3 process models that ship with TestStand, and majority of the time, these work perfectly well for what you want to do, and you can just use tweaks and changes in your specific TestStand sequences for your tests to override some of the behavior of the process model and not have to do what I'm talking about in this presentation. But if you want to continue it, then you can make further changes in there. So there's also user interface, where you've got some of the custom user interfaces like Resonate showed off earlier. You've got operator interfaces, so you can have different between the developer environment and the operator environment. And then you've got your test code, which can be written in LabVIEW, Python, etc. All the different code modules, and they actually build up your test. And that's essentially what's running in TestStand. So the sequences side of things, if you have a process model, it's just another sequence file. So just like you develop for your test application, it's a series of configurable steps that run a test. And the process model is a specific type of sequence file, and that allows you to modify the behavior of some of those sequences and turn them into execution entry points, configuration entry points, and callbacks that the developer can then use to implement their final testing. And of course, you can still just use normal subsequences if you've got code to wrap up in there. So why might you want to modify the process model? Well, if you've got mass changes that you want to apply to all your test stations and all the code that applies in your test facility, then process model might be a place that you want to implement that. So some of the examples that I would go through, log files. So it's software, we're big into our log files. Liam's going to give you a talk on it tomorrow, or later today, one or the other, tomorrow. I'll give you a brief introduction to them by modifying our TestStand process model, add in logging, adds in some extra debugging capability that you might want to implement for your particular sites. You could also modify the way that the operator interacts with the test system by adding in different execution entry points depending on your testing. And then there's also configurable callbacks that you can put in where your developers can override the behavior of the process model for their specific needs for whatever that they're testing. And of course, you can modify error handling as well, which we're not going to touch on too much today. So first off, execution entry points. The sequential model that ships with TestStand has 2 execution entry points. First one on the left here is TestUT process. This basically goes through a loop iteration where it initializes all of the background information. So it initializes all of your results processing, database communications, results gathering at the start of the test. It then pops up a message to say, put in your UT serial number, stores that information, continues through. And then this main sequence section is basically a callback. So your calling code can override the function that happens here. And that's basically where your test happens. Okay, so each of these points is a callback, which we'll talk about in a little bit of time. After you've done your testing, you gather the results, display any UT results to the user, generate test reports, and log to a database if you have one. If you don't want to continue testing after that point, you can go to the cleanup section where it cleans up all of those processes. Otherwise, loop through, continue, rinse, repeat until you are finished with your workday. The simpler option is a single pass process where it basically does the same as the TestUT process, but it does it once. So set everything up, run your test, close everything off, report at the end of the day. Job done. So with the callbacks, There's a number of different callbacks that you can do. The green ones on the left-hand side here are process model callbacks. So they live in the process model, and they're the things that you might want to add into or change the default behavior potentially, or allow developers to change behavior of your process. The process model post results down the bottom left there, I don't know if you can tell, but it's a purpley color. That's an engine callback. So that can be called at any stage. It doesn't have to be at the process model. It can be in your calling sequence. And essentially that overrides the behavior of the default engine. So if you want to add things in, like logging each of the steps, which we'll do in a second, you can add it in with an engine callback. Caveat to that is try not to put any intensive code in there, because you're doing an engine callback. They get called repeatedly and often. If you put slow code in there, it's going to slow down your whole test and cause you many headaches of trying to find out where it's going wrong. So we'll look at adding some of these in a demo here. So on this screen, I have a virtual machine running TestStand 2025 and LabVIEW 2025. So forgive me when I go into LabVIEW and I zoom by accident instead of changing the case structure. My muscle memory still does the wrong thing. So TestStand in general is a configuration-based tool. I've just got open a custom sequential model here, but in order to find from the start, if I go into examples, demos, and mobile tests, which you can find by going into run, and then typing %mark TestStand public %mark, that will take you to the examples folder. Unfortunately, with this version, I'm not sure if it's a 64-bit issue, but it takes you to the 32-bit examples folder, which doesn't exist. So feedback for NI. This was a fresh install. I probably broke something myself, but it goes to the wrong place. Yeah, furiously taking notes at the front. So it's quite possible I rushed through the installation and screwed something up. So take that with a pinch of salt. Definitely not my fault. So one of the examples, which actually Eli had in his slides as well, so I'll follow on from those, is the mobile device test. It actually uses an engine callback straight away, which is the sequence file load, which gives us this nice pop-up and says what to do. So it's a nice little tie-in straight away. I'd recommend if you're making any changes to these examples, make a copy of them before you make any changes, so you've got the original to revert back to if you need to. And same thing for process models. So to find the process model that it's using, you can go down to the bottom left, as the Nigel demo showed, and double click on this, and it takes you to the sequential model. Or you can load it as a normal sequence file. So I'd highly recommend going to File, Save As, find a new place to save it. Oops, don't override that one. I'm not going to use it, so something like that. And then you can start changing your process model from there. Don't modify the default one unless you want a big headache and have to reinstall to get it again if you haven't got it in the source code repository, which it'll be in the NI folder, so it's unlikely to be in your source code. Okay, if we want to then use that function, as Eli said, the controls are sort of hidden away in a few different dialog boxes. So until Nigel's available and can do it all for you, there's two different options. So you can go to Configure, Station Options, go to the model, and change the model in here. Or you can go to Edit, Sequence File Properties, Advanced, and then change it from using the station model to a specific model. And then select which one you want to use. And you notice down bottom left, it's updated, so you know you're in your safe version, if you like. Okay. Of course, I've changed the one I told you not to change, so I'll close that one and open up the demo version. If if I can find it again. So sequences, entry point demo. So if I hover over this, I've got the different entry points, execution entry points that are available for this, this sequence file, and that's pulling them directly from the process model. So the defaults, like I say, test UUTs, single pass, and then every sequence you can run just manually without the process model. So that's if you want to do some debugging, run it without capturing the results, etc., just as a standalone sequence. So useful on that front. Most of the operators will either use one of these two functions. And obviously, if you want to limit them, then you can go to your process model and just delete the one you don't want, and then they've only got one option. So if we save that, come back up here, it's updated. They can't click the wrong button anymore, and you're safe. So if I go back to the process model itself, one of the things I wanted to highlight before I give you a quick run through without modifying it, if I do F9, do a breakpoint in here, then go to our test sequence, run single pass. So we'll see when it first starts up, the first thing that's called after a few engine callbacks is the process model. And we've come in here, as you can remember from the slide previously, I'm sure, we've got a bunch of different sequence file calls here. So sets up all of the process models, the model plugins. So this is model plugins is the results processing and all that side of things. There is a way to add in your own model plugins, but as I said at the start, I'm not going to dive into that. We did have a quick foray into it, but it took us a couple of hours to basically say, no, we're just going to do it manually. So in our system that you might see at the end, we've got some MES calls. So they're web service APIs that get called. We add them directly into the process model. The better way would be to make a model plugin. We found it not intuitive to set up. I wanted to customize the types that were used in the process model, and it complained. So I gave up pretty quick and just went for a manual approach. But the problem with the manual approach is you can't change between the results processing that you'd like on the station. So it's a caveat, but it works well for our situation. Okay, so the thing I wanted to show you here, of course, when I've come to do the presentation, I don't have my sequences view. I've got to try and find out where it is. Yellow, if you can see it, sequences. Let's just do it fresh. There we go. So reset the, might be because of the screen res. Maybe. Live demos, there you go. Sequence files, no. Let's just get rid of these and see what happens. View. Thank you. Oh, it's because I'm in an execution, sorry. Ignore me. I'm going down here. So this is actually what I wanted, believe it or not. So the variables, they change when you get to the process model depending on where you're calling a code from. So it's quite a tricky place to debug, but if you put a breakpoint in, then you can see the live variables that are in there, and don't get confused if the sequence window disappears. It's supposed to. So one of the things that is useful potentially is the path of the calling function, the calling sequence. So if I go into the run state section, scroll down to the bottom and go to process model client, then in here you can see the sequence file name of the calling sequence. Very useful if you want to have dynamic log files that are based off of the name of the sequence that's calling it, which I'll sort of show you a bit later on. But if you want to do any customization in here, put a debug point in, break out, find the variable that you're looking for. In the parameters section, so I won't go into too much TestStand sort of training, but the parameters are how you pass data into your sequences. The parameters can change in the process model depending on what callback you're using and what various steps are being called, what step type, etc. Each of the different step types changes when you go into a callback and things like that. So if you need to debug stuff, breakpoint's your best friend. Okay, so if I continue from here, this is just the default process. We get our main sequence, which is running on that left-hand side there. And yeah, we won't have any errors on our thing. We'll just go through. One thing to note, I've slowed down the tracing here just so you can see things. To do that, you go into the configure station options, and this tracing, usually you'd have it ramped up to fast and it zooms through, but then you won't see anything. So I've slowed it down just for the demo purposes. Maybe I've slowed it down too much. But then when it gets to the end, hey presto, you've got a report. So that's the default sequential process model. Works a lot of the time, like Eli was saying, he's never modified the process model. Yeah, a lot of the time you don't need to. And you can use callbacks to modify the code where you need to. So if I want to add in some universal logging, so software like I say, we like to have a debug log file that we spew out from our systems and add in that functionality. So I've added a sequence file. I will open a sequence file called tlog. So this is just our built-in one, but the sequences are back. So yeah, we can add lines, add links, show the log file, etc. This is based on a HTML log that Lynn showed off last year, potentially, or 2 years ago, but we'll talk about tomorrow as well. So if we want to add it in, we'll go back to our entry points, go to our sequences. Sorry, this is the this one. So the process model. We could just add in a sequence call. So use tlog, start tlog, and then we can put in our parameter names. And this is where I'd put in the stripped down version of that file path and make a custom one. But what I'm going to do to sort of cheat is do do you guys have Blue Peter? You ever have Blue Peter, or is that a UK thing? UK thing. Here's one I prepared earlier. Yeah, it's using slang that Australians don't know. But yeah, here's one I prepared earlier. I'll copy it over to our new one. And the screen resolution is going to screw me over a little bit. And I'll take the sequences that I would add in manually, and I'll show you how to add them in manually shortly. So just copy and pasting from these guys in here. So if I want to add these callbacks in manually, what I do is go into a new sequence. Sorry, if it's a callback. If I want to call back and override the engine behavior, I can go to sequence file callbacks. And then there's a list of all the engine callbacks that you can possibly override. And yeah, you just tick it and it shows up. So sequence file prestep, for example, if I go in there, adds this function, currently does nothing. You could add in logging steps or whatever you want to do in there. I'll show you the one we've got here, which is the process model prestep. And basically we go in, we're splitting down the sequence file path, so we find out which sequence is calling this function, because we don't want to log all of the tlog calls. So we check if it's a tlog call, remove that, don't log that one. And then we check if there's or what step type it is. So if it's one of interest, such as a test step or an action, then we'll record it in the log file. And if it's a sequence file, we add this sequence file name to that step. So we just check whether it's what type it is. And these are the things that change sort of dynamically based off of what step it is. And this is where you want to, when you're creating this function as an architect, you want to go in, debug it, breakpoint, stop at this point, go to your variables section and have a look and see, what's my step information here? Because when you're doing it, when you're not running, there's nothing there, so, because it's variable. So yeah, breakpoint to get all that information. Okay, let's save that and then run the, excuse me, run the code again. Of course. So I put the variables in. Hopefully it's just the one. And that's the wrong place. Yeah, always good. And having to sort of do a limbo to talk into the microphone and run the mouse at the same time as well. So, does anyone remember what it's called? Project name, probably. No, that one's there. Oh, Firepath. Let's give it a whirl. If not, I've got my fallback of everything's done. So, well, it's got to this stage, so let's give it a run. Going through. Whilst that's going, if I go into my file view, I'll find where the function should be. No, okay. I will run it on the other one. Okay, so everyone remember how we changed process model? Go in here, go to the complete version, which in theory should work. And of course, I closed my windows because I'm silly. So SWS, beam station. Okay. I promised it was working earlier. All right. What was the going nuclear? We'll go back to the other example as well. It shouldn't be, no. It should be setting up the model. It's setting up the log file, sorry. So let's just, sequential model complete. Sequential model complete. It should be going into single pass. So it should be setting up beam station. And the project name should be beam station. Let's give it a run. This is a future sneak peek. Custom lab view for your callbacks to add in process models, enabled calibration and things, and model numbers. Okay, let's see whether that's produced it or not. Hey, there we go. So, yeah, we've got our step information, in theory, nice and quick. So we added in a couple of engine callbacks in order to enable this, and we want this functionality to be the default for all of our stations. So we want to gather the information before we get to a step, because we had a customer that came to us with some existing TestStand code and said, sometimes it flakes out and we don't know why it breaks. So, well, let's start off, introduce some logging. find out what step it gets up to when it breaks, because they weren't quite sure where in the test process it was falling over. As a headless system that was running for sort of 16 odd hours, and sometimes it would break in the middle. So yeah, adding the log file in enables us to find where the log file got to, and then identify where the issues were and start to refactor that code and make it a bit more reliable. The extra information I've added in here, which I'll go through in a second, is some useful stuff like the making it green when it passes, making it red when it fails, storing test results, etc. One thing I wasn't expecting when I set up this demo is that some of the pictures come across as well, but that's a nice added bonus. I can't say for sure how that happens, but it must be something in the HTML coding that Liam's going to talk about, which is good. Yeah, this demo has a lot of funky text in some of the string checks and things, but we're logging it all in the log file and coming through and closing off at the end. So we've cleaned up the report log in this case. We're just doing a single pass through. For most of our customers, we do repeat loops through using the test UT function, but for this demo, we'll use this. So I'm going to go from the complete version and fill you in on what I would have done live as we go through. But the copy and paste I did at the beginning was at these functions here. So we've got the model pre-step, which I've shown you already. If there's an error, we want to record the error and log that. We do that both for the sequential file and the process model. And process model post results entry list is or list entry is the way that we format the string into the green and red text, basically. But in order to do that, highly recommend doing the debug trick that I showed you before, because there's all sorts of information that changes here, and you might want to capture all the different types of information, so you can have a quick squiz through. So based on the test type that we've got coming in, we enable a Boolean flag. The Boolean flag then goes into different states and formats the string based off the state going through. So for example, numeric limits has a lot of information around what's coming out. Let's see if this shows it. So we've got the test step, we've got the comparison type that comes out of it as well, and obviously the result, which is very important. You might also have the test limits as well. So we've got lots of string formatting, eventually culminates into a log file. We also have a pop-up for the operator here if they want to continue testing or abort testing if it's a fail scenario. So sometimes they want to quit and get out of it. Other times they want to continue testing, finish a certain test before they go and rework the unit and retest it. So that sort of functionality lives in this process model. Again, global for all stations now, rather than individual test sequences. Another thing that we modified, and this is a simple modification. So we've got the extra logging in the start, but we've also got this report terminal. Nothing popped up when I ran because I've got the variable set to false. But this is a function that Tim at the back there, or wherever Tim is, Tim in the middle there, helped write for some of our customers, because they're saying, I'm running through a test. I can't really keep track of the tracing that's going on in TestStand. It's jumping between things, and we could have slowed down the tracing or stopped the tracing going into subsequences so it's not as jarring for the operator. However, this is a good solution where we basically have some LabVIEW code running in the background, and it uses that string that we formatted for our log file and dumps it into a LabVIEW GUI so they can see, this test has passed, this test has passed, this test has passed, this test failed, and this is the parameters why, etc. So those strings we actually use in multiple places. So that dialog that pops up to say continue or abort also has the information on that is in the log file. Very useful for everyone involved. So if I enable that in our station globals, it's already enabled, it must have been off the screen. Run it again. So I just got a pop-up for serial number and the model number. There we go. See if I can find where that window's gone. It's hiding. Right. You have to trust me. It comes up on their screens. So let this finish off. Go back into the process model. There we go. So another thing that is useful for architects to enable for developers is custom callbacks and enabling callbacks for the operator. So if I go into, how much time, Chris? 10 minutes, cool. If I go in here and start a new sequence, let's call it example for now. That's close enough. Go into the sequence properties and the model that's being used. So normal is obviously a normal subsequence, but you can change it to a callback, execution entry point, or configuration entry point, depending on what type you want. So if I want a callback, I can do that. If I save this, this is now a template that can be used. I could drop it into my execution entry point here. Insert sequence. Example callback. Use the current file. Find it in the list. Fortunately, I spelled it badly, so it's easy to find. And then that will get called in your sequence, in this case, before the main sequence callback. So it's a way of separating out your code and enabling different callbacks for the developers. So in this case, if I want to then use that in the calling sequence, this is now my mobile test device, mobile device test, sequence callbacks, and I've got all the model callbacks down here. I've got my example there, and I can add in some custom functionality. So some of the ways we use that, calibrating the setup. And the reason I do that, and I'll go combine this demo with the next demo. The reason I do use a callback here is because I actually use the calibrate setup as a configuration entry point. And configuration entry points are basically additional functions that you can add to the TestStand menu up here. So the results processing and model options are the default configuration entry points. And then the others are configuration entry points that we've added into the process model. So if I wanted to do calibrate setup, yeah, I'll save. Then I've got this function that is called from our calling sequence, so I can have calibration procedures that are related to our specific DET and specific setup, and then override the behavior of the process model, so I can call it in two different places with the same piece of code, basically. So I could call it within my test sequence because it's available in our calling sequence as a sequence, and I can call it through the configuration entry point window, which the operator might use before they run a test. Okay, and this is just a press this, done function. Same thing with a lot of these other things as well. But if I want the default behavior, then I can leave it in the process model. So for example, I've got this show latest log file. That means the operator can come up here, go show latest log file, and then again, Tim's made this HTML viewer. Unfortunately, it doesn't have search just yet, but maybe one day. And you can see the latest test report that's in there, or navigate to other ones. Sorry, not test report, log file. And this is in conjunction with the standard test report that comes with TestStand in this case, but you could also customize that. Cool. So wary of the time, I'll go back to my presentation. And yeah, already mentioned these configuration entry points used for customization, so the operator can change things, change your station options. Just remember to save the station globals if you modify them in a LabVIEW function or anything like that, because they don't automatically save. You have to call a specific expression, which you can find online, I'm sure. Demo is basically the demo I just did. And yeah, finally some UI interactions. So these are some of the TestStand examples that we've got with customers. So down the bottom right there, we're running some RF testing. And this, if you remember back to 1.5 years ago, Liam spoke about his dynamic menus architecture. And this is TestStand integrated with that. And this particular customer wanted to have all their test sequences available to the operator to push one at a time, or have a test all button which is all handled inside of this LabVIEW front panel. And then we've got the test execution, which you can sort of see there. So when they select the test that they want to run, they just click one of these buttons. That sends a message down to the process model, which we've got custom code running an extra loop in there to monitor this function. Once they press that button, it then launches the sequence they want to run in the calling sequence that or sequence file that they've created. So yeah, there's an extra layer in the process model where it's got this monitoring code and UI to and fro, some handshaking in there to have a smooth experience for the operator. And then, yeah, when you go to the test execution screen, that's where you see the standard tracing of TestStand. And then there's buttons for stopping, starting, etc. Yeah, and up on the left, there's a part of the parallel stuff that I was talking about earlier, but we won't dive into that at this stage. Demo, maybe? No? In that case, questions? I shouldn't have quit. There we go. Thanks very much.
Thanks, Pete. Okay, do we have any questions? Chris?
Pete, I got burnt very early on about tampering with the process model, so I think you're brave.
Yeah, this reminded me of something I should have said at the beginning. Don't do it if you don't have to. And definitely make a backup.
When I'm trying to figure out, like, I was under the impression that you can do most through callback overrides, but obviously you can't.
You can do most things through callback overrides. Like, we could have added in the logging into some of the callbacks that exist already. We wanted it even before that so we could see things happening in the process model, especially when we came to the UI customization. It was sort of needed for that because we had an extra loop in the process model that was monitoring that, and we wanted to log that to debug it when we were developing. So yeah, most things, I'd say 90% of things can be done with the callbacks that exist already, but yeah. If you need more, this is how.
Secondly, maybe it's a question for Liam tomorrow. Is Tlog a open source?
No. And HLog isn't open source either. So we had to make some modifications to switch to a TCP backend instead of a queue backend because of issues with packages and built packages, which slightly related to TestStand because we tend to build our own packages and not use the TestStand building tools. So yeah, the queues stopped working when we started doing that and having classes and things inside packages and naming structures all changed, etc.
You don't use packages?
Oh no, the pack libraries. Sorry.
Oh.
Yeah. So we've got a number of packed libraries that the queues don't agree with.
Just to confirm, so you were deploying as PPLs and you stopped, and now you're deploying as what?
So we still deploy as PPLs, but the logging functions are now TCP a server instead of a queue in LabVIEW. So it means that we can use the logging among multiple application spaces. So TestStand's its own application space and LabVIEW's its own application space. They can use the same log file without having to spin up two engines, etc.
Okay, so your comment about not using NI packages.
We'd like to use the NI packages, but we use packed libraries.
Packed project libraries.
Yeah, that's what I mean when I say packages. Yeah.
Okay, and then you're just not using NI packages to deploy that.
One day we will. We're not at the moment.
Just curious.
Yeah, one day we will.
Okay, that's everyone. All right, very good. Thanks, Pete. Cheers.
Thanks.